Greetings and welcome back to our discussion on chemical bonding in terms of atoms. So today we're going to talk about the two types of bonds that we're going to study in this class. And so at the end of this lesson, you'll be able to describe both ionic and covalent bonds and identify the particles produced by both ionic and covalent bonding. So here we go. Let's start with ions. So we talked previously, an ion is a charged atom caused by gaining or losing electrons, meaning that atoms have more or less electrons than protons. So in this case, when potassium becomes an ion, it has one valence electron now, so it's going to want to lose that one. So we're going to have potassium with a positive charge and no valence electrons. This ion, or this electron, is going to go right there, which means you're going to have potassium bonded to iodine. It's now going to have 8 valence electrons. It's going to be negative. I will do magnesium and bromine with you. So magnesium has 2, so it's going to lose 2. So it's going to be a 2 plus charge. And bromine, because bromine has 1, 2, 3, 4, 5, 6, it only needs 1. It's going to gain 1. So we're going to have bromine here. 1, 2, 3, 4, 5, 6, 7, 8 with a negative charge. And we're going to have a second bromine that looks the same way. So that's what we're going to have. And so I would like you to do that with magnesium and chlorine, and then hit the play button, and we'll go to the next slide. So when this happens, these substances form what's known as an ionic bond. Ionic bonds are formed from the attraction of oppositely charged ions. So in this case, we have sodium and chlorine. So sodium had 1 valence electron, and it lost it. It went over here to this chlorine atom. So sodium becomes positive, chlorine becomes negatives. Just like everything else that you've ever heard of in life, when you have a positive and you have a negative, what are they going to do? They're going to come together. And that's exactly what happens, is you have a positive and negative come together, and that is your ionic bond. These tend to occur between metals and nonmetals, because remember, metals have 1 to 4 valence electrons, nonmetals have 5 to 8. So it's easier for metals to lose electrons, easier for nonmetals to gain. And the net charge on all of this, if it's stable, is 0. So I had +1, -1, stable. Those are ionic bonds. Really quick, think back. I want to know, pause the video, and then listen to this, then pause the video. I want to know, what are ions? What is an ionic bond? What charge does a stable ionic compound have? Pause the video, answer those questions, hit play, and we'll continue on. So we have ionic bonds, and then we have these things called covalent bonds. So covalent bonds form from electrons being shared. That word is really important. These occur between nonmetals and nonmetals, and these form what we call molecules. Typically refer to covalent bonds as molecules. Ionic bonds form compounds. Is it wrong to call it the other way? No, absolutely not. You can call ionic a molecule, you can call covalent a compound, that's fine. But in general terms, when you hear the word compound, I want you to think ionic bond. When you hear molecule, I want you to think covalent bond, because most of the time that's what's happening. All right, down here we have 2 chlorine atoms. Notice both of them have 7 valence electrons. They want to have 8, but if I give this one away, now I'm down to 6, so that's not going to work for me. And if you gave yours away, you're going to be down to 6 as well. It's not going to work for you. So what if we shared? What if we put both donated 1 and put it in between us? And that's exactly how covalent bonds work. So they form this kind of a setup, and that this line is indicating 2 electrons, one being shared by either one, and the rest of them fill their outer shell. So these 2 are now stable, they're now happy, and they're sharing 1 electron. This is known as a covalent bond. We can also have a double bond. So we look at oxygen. Oxygen's got 6 valence electrons, so it wants to get 2 more. Well, this one also has 6 and wants 2 more. If I take 2, one has 8, one now has 4. That's not going to work. So in this case, like chlorine donated 1 electron, oxygen can actually donate 2. So I can have 2 lines here because there's 1 electron at either end of the line. And we space the rest of them out here. This is known as a double covalent bond. And nitrogen has 5 valence electrons and wants 8, so it has to donate 3. So for nitrogen, you have... Ooh, the last one didn't want to work for me. For nitrogen, you have 3 of these, and then you're left with just a single pair on the outside. So we have 2, 4, 6, and then this would be 8 for this one, and 2, 4, 6, this would be 8 for this one. These are double bonds and triple bonds. There's 3 types of covalent bonds you can have. Really quick, how do ionic bonds form? This is the last little section. How do covalent bonds form, and what happens in a double covalent bond? Answer those, and then we will continue on with the rest of this little unit. Okay, question. If you have a sibling, have you ever tried to share something with them? You don't have a sibling, have you ever tried to share something with either a best friend or a cousin? If you have, how'd that go for you? Because I'm going to guess it didn't go real well. If atoms were siblings, they would be the exact same way. Not all elements like to share electrons evenly, and when this happens, they create what's known as a polar covalent bond. In a polar molecule, in a polar covalent bond, there are positive and negative ends due to unequal electron sharing. So polar covalent bonds have unequal electron sharing. Think of it like the Earth. The Earth has a north pole and a south pole. These are opposites. Atoms are the same way. They have a positive end, so instead of north and south, it would be positive, if I have a molecule here, and negative. So that's all done based on electron sharing. So this side's going to hug the electrons more, this one's going to give them up more. For example, water. We said that oxygen has 6 valence electrons, and so it's sharing to get its 8. 1 with each hydrogen. Because oxygen is a bigger atom and it has more pull from its nucleus, it's going to hog these electrons, which is going to give it a slightly negative charge. Because hydrogen is not going to see these electrons very much, it's going to give it a slightly positive charge. I can show you in class how this looks and how we've come to discover this. You can actually see this in action. But water is actually a polar molecule. So it doesn't have a complete charge, but it's got a slight charge. The water is polar. Oxygen is slightly negative, the hydrogens are slightly positive. In some cases, atoms do like to share evenly, and they are nice siblings. These are called nonpolar molecules, nonpolar being without poles. So in this case, electrons are shared equally. Most of the time, this happens when you have 2 of the same element bonded to itself. So nitrogen bonded together, oxygen bonded together. We can also have something like this, where it's carbon tetrachloride. So there's 4 chlorines all pulling opposite directions, so it's going to be an equal pull and make this neutral. But nonpolar has equal sharing in some way, shape, or form, and so there are no partial charges on the atom or on the molecule. Okay, here's your last set of questions. What are the 2 main types of bonding? What are the 2 types of covalent bonding, and how are they different? And then give me an example of an ionic bond, a polar covalent bond, and a nonpolar covalent bond. If you can do that, we'll be good to go. If not, please come see me, ask me questions. I would like to help you out through this and enhance your understanding of this material. But thank you for your time and attention today. I look forward to seeing you in the future, and I will talk to you later.